Howdy guys. In this video, I'm gonna show you how to read the psychrometric chart to calculate the different properties of dry air. We always start with two of them in order to figure out the rest. So I'm gonna solve the exercise that we saw in the previous video. It's gonna be like a continuation from the one from the sling psychrometer. So if you haven't watched that one, I highly suggest to go watch that one first and then come back here because that's gonna be the starting point. So I'm gonna start by writing down the two properties that we found out from the previous video. So using that sling psychrometer, we realized that the dry bulb temperature was 21 degrees Celsius and the wet bulb was 17. So now I proceed to, I'm gonna go to the chart here. I'm gonna show you where it is located. So as you can see here, it says dry bulb temperature on the x-axis. Here it goes horizontal lines in increments of 5. So it would be 15 here, 20. We are looking at 21 degrees Celsius. So our starting point would be right here for the dry bulb temperature. Then the wet bulb temperature, I should remove this. You can see the lines go diagonally right here. So here you see a 25. This would be 26, 27, 28, 29, and this one is a 30. So here's the 20. We're looking at 17. Here's 15. So the next line would be 16, 17 would be here, right? Oh, it doesn't let me write. Yes. So this is 15, this is 20, this is 19, 18, 17 would be this line here. This is our 17. This diagonal line. Okay, so I'm gonna proceed and go draw a line from here, following this line until it crosses that intersection. It will be about here. And the same for the one at 21 for the dry bulb. So I'm just extrapolating. As you can see, this is where the point where they meet. This would be the intersection between these two, 21 degrees Celsius from the dry bulb and 17 from the wet bulb, okay? So once we have that figured out, I'm gonna put it in green. We can go all the way to the right side. So here is my intersection point. And I just extrapolate all the way to the right side here to find out the humidity ratio. This is the scale for the humidity ratio. The units are here in grams, grams of water per kilogram of dry air. And now I need to figure out the value. Here is 12, 10, 11, so it would be about 10.5. Okay, so let me type that. W, or the humidity ratio, would be equal to 10.5 grams of water per kilogram of dry air. All right. What's next? Do you see the lines, these curves that go here? You see the 90, so this is the line for 90. This is relative humidity, as it points it out here. So this is the line, the curve for 10, 20, 30, 40, 50, and so on. So these are the lines that we're gonna read to find out the relative humidity. This takes forever. All right, so we go back to our intersection. As you can see, is between these two, the one in 70 and the one in 60. So 65 would be maybe somewhere around here, but our point is right here. So I would estimate it's about 66, 67%. Can you see that between these two, between 70 and 60? Here is about 67, which is actually the same value that we obtained from the reading the scale in the sling psychrometer. So the relative humidity is about 67%. Okay, what about the enthalpy? Let me erase this one. The enthalpy is located here in this diagonal. The way to read it is you just extrapolate this line as it was for the wet bulb temperature. So I would just go straight. I don't want them to overlap, so I'm gonna put it here. Okay, how about here? You see, I'm just extrapolating all the way to the top left, this continuous line, in order to read the enthalpy. So here we have, this is 40, 50, 45, 46, 7, 8, so about 48. So our enthalpy in that case, I'm gonna write it here so as I have more room. Our enthalpy would be equal to 48, and the units are kilojoules per kilograms of dry air. All right. So what else can we calculate? Here we have another scale for the dew point temperature. So what we have to do is just extrapolate the same line that was going all the way to the right, the one we use for the humidity ratio. I'm gonna put in a different color. So if I just made that line keep going, I want to make sure that it's okay. So it will be somewhere about here. Is the one on the left. So pay attention to that. This is the dew point temperature in degrees Celsius, because the one on the right is vapor pressure and millimeters of mercury. So we're looking at the left. Here is the degrees Celsius, is 10, 15. We are somewhere here between 14 and 15. So I would say 14 and a half for our dew point. So the dew point temperature would be 10 and a half. Oh, no, we said 14 and a half. Here is 14, 15, 14.5 degrees Celsius. Okay, so we have the enthalpy down, enthalpy, dew point, humidity ratio, the relative humidity. Where we are missing is these other diagonal lines that go vertical for a specific volume. So you can see here, volume, these are the units, cubic meters per kilogram of dry air. Here we have a value for 0.86, 0.88, so therefore the one in the middle is 0.87. Our reading is located here, so this would be 0.85, 0.84. So it would be between these two, correct? This is the line for 0.85. This would be the line for 0.85, and this would be the line for 0.84. So here would be about the middle, 0.845. So I would say about 0.847. So for a specific volume, that's 0.847. And the units are cubic meters per kilograms of dry air. Right? So where we're only missing now is the density. And you remember the units of density, so it would be it would be mass divided by volume, right? So it would be the inverse of that. So density is equal to 1 divided by specific volume. And that would be equal to 1 divided by 0.847. Right. And that would be equal to 1.18. That would be the inverse of the specific volume, therefore is kilograms of dry air per cubic meter. So we got all the properties down. Wet bulb temperature, dry bulb temperature, the humidity ratio from here, relative humidity along the curves, the enthalpy reading here all the way to the top left. The dew point is the next scale all the way to the right. Specific volume, these other diagonal lines that go vertical, and the density is the inverse of that specific volume.